This is a cute little lab. I have the kids play with oscilloscopes in the circuits unit. This oscilloscope is a prototype of I think it's like a $14,000 oscilloscope from Tektronix. They never actually went into production, so this one is, you can see they've covered up the port there, like, you know, don't use the diagnostic tool on it or it'll destroy it. What I do is I have the students use this to analyze the full wave bridge rectifier. Okay, and what you've got is the transformer makes a low voltage AC that feeds into this side, and then it goes through this circuit. Okay, it goes through that circuit, and it comes out as DC with a huge ripple. And then I have a load on here. This load just sort of actually creates the ripple, right? And then this capacitor right here takes out some of the ripple on that. Menu off. There we go. So first thing we're doing is we're looking at the, and you can just press this auto set button. Menu off. There it is, right? And then we can add measurements on this, right? So they've already done the part where they manually do all this stuff, and then they sit down and they get to be amazed by this. Let's see if I can remember how to do this. Actually, the directions are right here. Measure button on the second row. Oh, here it is, measure button. Add a measurement of that. Okay. And then that's cool. It shows the frequency, it shows the peak, the RMS, all that stuff that they had to calculate by hand. So that's kind of cool. And then what they're going to do is they're going to take this and attach these guys to the other side. And then these things, well, you know how to use an Oscilloscope Pro. I hope. All right. And then if you look at that other side there, you can see it's basically the absolute value of sine, but it's actually the absolute value of sine minus 0.6, because that's what the diodes do, is they take 0.6 off of it. Because the voltage drop over a diode is always roughly 0.6. And that's, you know, this is DC. We could charge our phone with that, but it's not ideal for all things, right? So what we're going to do is we're going to take this diode this capacitor and actually hook it in parallel with the output. And now you can see it's got, I hit the auto set button, draw me a pretty picture. So that is the DC output with ripple on it. Okay. Now without this load on there, the ripple would go away. Let me just show you that. Oh, it's just perfect DC, right? Okay, and I just wanted to show the ripple, so I put a load on there. And there's the thing. Come on, baby. Doesn't want to go back in there. There. Okay. And I just put a big resistor on there. It gets kind of warm, so I put a heat sink there. But, you know, anyway. And this used to be a required lab for IB. I don't think it's required anymore. So I don't know if it's worth doing. It probably is. I don't know.